Yeah, live. It is way before 7. A full hour basically. 5:56. So how's everybody doing tonight? It's Friday night. Hopefully everyone's got cool plans for the weekend. Today I want to talk about intake manifolds, specifically carbureted intake manifolds. And what we're going to talk about, we'll talk about LS stuff, but it carries over to everything. So small block Fords, small block Chevys, modular Fords, Dodges, all these things, because we see the same thing happen when we talk about single plane and dual plane intake manifold comparisons. And one of the common questions I get when we do this, because guys have seen this a lot, and guys that are new to it, if you haven't seen it, whenever you test a single plane manifold versus a dual plane manifold, obviously the exact thing that you're going to test the combination that you're going to test it on, and the exact two different intake manifolds, a single plane and dual plane, whichever ones you choose, are going to dictate what happens ultimately in the results. But generally speaking, here's what happens. A dual plane makes more power down low, and then a single plane makes more power up top, usually. In some cases, like the one that I was just looking at today before we got on here, I was looking at a 4.8, and that's exactly what happened. The single plane lost a bunch of power down low, but it never made any more power than the dual plane all the way up and beyond the horsepower peak. So the dual plane was basically as good at the power peak and beyond that, and then just better everywhere else. So when we say that the dual plane is better down low, it doesn't mean that it makes more power at 2,500 and then is not as good as a single plane higher up. We see normally what we see when we compare these is we see some sort of crossover point, some sort of crossover RPM. When we're testing these on the dyno, we run from, let's say, 2,500 to 6,500. And then where we run these in RPM range is going to dictate which one of these is, more favorable, how big the combination is in displacement, how much camshaft we have in it, how much cylinder head we have on it, where this thing wants to make power. It's going to help dictate also which one of those manifolds may or may not be a better choice for it. So, but even when we put a combination together that's like, let's say, a 7,000 RPM deal where a single plane manifold might be able to come into its own, there's still going to be a crossover. The dual plane is going to be better in some RPM range, depending on, like I said, primarily the displacement of the motor, but also the power output and the camshaft and cylinder head and stuff. But the dual plane is going to be better down low, let's say up to the mid-range part, or even all the way at the very top. And then the single plane could be better on the big end. That's pretty normal. And I think it's fairly well understood now that I've done dozens of videos on that for all of the different engine families. We see that if we run a RPM air gap at a Victor Junior or Super Victor or whatever, if we do those kinds of comparisons, we see that. That's not revolutionary. The question I get more often than not is when I do those tests and we show those results, we show the single plane and the dual plane, we see that the single plane loses power down low. The question always is, when you show them those two graphs, hey, look, this is what they do. One of them is better than the other down low. How do I get that back? And then we get the internet warriors. Oh, we can tune that back in. So we could add a bunch of timing there. We can get it with the tune. We can change the air fuel. We can do these magic things. One of the things that they don't realize, the people that are making these comments, a lot of them have not done a lot of testing in their lifetime, or even watched enough videos on actual testing in their lifetime to make a qualified comment. But what they don't realize is that we didn't just put those manifolds on there and hope for the best. Each of the combinations was tuned. Obviously, this is a lot easier with an EFI version of each one of these manifolds, but with a carbureted one, we could do the same thing. We tune it, we don't spend an infinite amount of time there because we have lots of stuff to tune or lots of other tests to run, but we do tuning. So we optimize the amount of timing that motor wants at that combination of RPM and chamber volume and piston design and stuff. It's going to want to make, it's going to need or require a certain amount of timing at a given RPM with those things. And then and at each RPM segment, it's going to want a little bit, as we go up in RPM, it's going to want a little bit more timing. The thing has to happen a little bit earlier for it to happen at the right time. You have to ignite it a little bit earlier because things are happening a lot faster. It's pretty normal with ignition. All of these combinations have, what we would call a maximum amount of timing that they respond to. And then beyond that, if we go beyond the amount of timing that makes the most power, when we run it on the dyno, if we go beyond that, it doesn't add any power. And if we go beyond that, it starts losing power. If we go beyond that, it starts losing parts from the motor because you're detonating it. It's going to hurt it. So that's not good. So it's pretty easy to see where that optimum amount of timing is. One of the misconceptions when we run these kinds of tests are that we just didn't give the single plane all of the timing, or that somehow the single plane could utilize more timing or benefit from more timing in that instance. We've tried that many times. And the power loss from the intake manifold is not a function of a lack of timing. It's a function of the intake manifold design. And so again, the question becomes, I could get all that back, but I just add a bunch of timing. That's great. You're just going to add detonation potential normally. You're not going to add all the power back. You can't do that because they are different designs. The manifolds themselves are producing a different power curve that has nothing to do with ignition timing. The reason that they're doing it is not that. And so therefore you cannot cure it with that any more than you could cure it with changes in air fuel too. So that's not the answer. The answer is because those things are different, but people want to know, how do I get that? How do I get that torque back from the single plane? Well, the number one thing that you could do is just go to the right intake manifold that makes the power curve that you want. And that's if you have a single plane on there and you want the thing to be more responsive, you should put a dual plane on there if you want the thing to be responsive and you still want it to be a carbureted induction system. That's the answer. Don't try to fix don't look at the problem and try to fix it with a bunch of other things. Fix the problem. If the intake manifold design is the problem and it loses low speed power because it's a single plane manifold or any other kind of short runner manifold, you should address that problem. You're not going to be able to fix that with camshaft. You're not going to be able to fix that with tuning. You could fix it with boost, which if you could get boost happening down low, you could fix that. You can also improve it a bit with compression. You could also improve it with displacement is a good way to do it. But this is another misconception when we talk about displacement, because we get guys that ask that all the time with camshafts and intake manifolds. Well, if that combination, if that single plane manifold lost a bunch of torque, if I did that on a 6-liter instead of a 5.3, would I pick it all back up? No, you wouldn't. A single plane and a dual plane are always going to do what they do. You'll have more torque down low with a 6-liter compared to a 5.3 with either one of the intake manifolds. So you're starting off making more, but there's still going to be the disparity between those two manifold designs because that's inherent in their design. So I always get confused when people ask that question. Well, can I cure that by just running a 6-liter? Well, yeah, yes and no. You can cure it, in the fact that you will have more torque. If you go from a 5.3 to a 6-liter and you had not enough torque with a 5.3 in a single plane, and you went to a 6.0 in a single plane, you would have more torque just because it's a bigger motor and it's going to have more torque. You didn't cure the problem unless you only wanted to get to a certain level. And that's the nuance. That's the thing that I have, I'd have to spend a lot of time explaining this, which I can't do in a comment. I can't write a dissertation in a comment trying to explain all of this. A bigger motor is going to have more torque. It's a simple thing. Doesn't matter which intake manifold you have, the bigger motor is going to have more torque. It will have more with a more displacement and a dual plane than it will with more displacement and a single plane. That's all going to continue to happen. So it doesn't cure that problem. A single plane doesn't all of a sudden work better on a bigger displacement motor than it does on a smaller displacement motor. But again, there's a nuance there. We have to talk about that. There's still going to be a disparity in the lower part of the RPM range. What will happen when we go up in displacement is the crossover point that we were talking about, where the single plane starts making more power than the dual plane. If we go to a bigger motor, what happens is that RPM range where that crossover happens is going to shift down a little bit. So it's going to cross over. The single plane is going to get a little bit better, a little bit earlier than it did before with a smaller displacement motor. That's typically what happens, but it's not a lot. It's not 1,000 RPM. It's not 2,000 RPM. It's hundreds of RPM. So it's not going to be a big change unless you do a big change in displacement. If you go from a 4.8 to a 6.2 or a 383, even better, or a 408, even better, then you can shift it a pretty good bit. But there will always be that sort of disparity. And the problem is, as we've covered many times in our discussions here, when you show people that graphically, hey, look, this one's better by this much. When you show them that, they want that back. Okay, how do I get that back? Well, it's hard. We talked about the ways that you improve low speed power, and you're not going to get it back. Sometimes you'll get guys chime in with, "Oh, I got a single plane manifold. I can fix that with a camshaft because you have a single plane intake manifold camshaft that's designed specifically to enhance low speed torque only with a single plane manifold." I would like to see that camshaft because I don't think that kind of cam timing exists. Again, people don't understand that, and the reason that sort of discussion can happen is because somebody probably did that. They had a combination, they had a single plane manifold on it, they had a camshaft that was probably also a little bit on the big side, so it was definitely soft down low. They put a smaller camshaft in it, and look, voila, it improved the low speed power, which it would have done with any intake manifold because they just went smaller in the camshaft. But now they associate that. Oh, this is that single plane camshaft. No, it's just a camshaft, just like it would. Both of those camshafts would also work with boost. They would also work with a turbo and a blower and nitrous and all of those things. It's just that nobody ever compares that. Nobody does the full whammy comparison to show you all of the other things that also happen. So when you're looking at single plane and dual plane, and I use that, we were talking specifically tonight anyway about carbureted stuff. But when you're looking at that, the way to cure that is put the right intake manifold on it. Now you can whittle away at it a little bit. If you put a dual plane on there and you want more low speed power, that's good. You maybe could put a 1/2-inch open spacer on it, or a divided spacer, or a 4-hole spacer, or a tapered combo. Try some kind of spacer on there so that you can get a little bit more on the top. But whenever you do that, you're usually going to lose a little bit at the bottom. You're going to be trading that just a little bit. But again, it depends on where you want it and what you're trying to do. The nice thing about a spacer is that that's something you could put on at the track. But the downside of a spacer for a carbureted application, especially if you're doing that, if you're putting a spacer on a dual plane intake manifold, you're more than likely going to have to do jetting to get that thing right. Whenever we do spacers, especially an open spacer on a dual plane manifold, you usually hurt the signal quite a bit down low and it gets lean, and that's not a good situation. So we usually have to improve that with, additional jetting. It's like going from a single plane manifold to a dual plane manifold or vice versa. You'll have to change the jetting. There's definitely going to be a jetting change required in your carburetor to get that to work, because on a single plane manifold, the signal is not nearly as good as it is on a dual plane. And so you usually have to add a bunch of jet to a carburetor when going to a single plane manifold. So hopefully everybody understands that. It wasn't too convoluted. We'll see what you guys got going on this nice Friday night. Where's the torque? Exactly. Our poll up. The dual plane intake is better than the single plane intake for 90% of performance applications. So that's kind of a yes or no kind of thing. So I'm going to scroll back here. Modular powers here. That's good. Tearing into the rod knock motor in the morning. So here's hoping the expensive parts are still good. A rod knock is not usually good, but hopefully, it'd be nice if it just hurt a bearing. Probably not. Just a rod, crankshaft too. Let me know what happens though. Arizona's in the house. Brandon, what's going on? Eric's here. Also, I think I might do a crazy thing and do the Big Bang thing in my car with a stock NPI short block and add a ring gap. Or do you have turbos that you're going to put on that? What did the little notch between the sides on the dual plane manifold do? It actually turns it. It's cutting the notch, cutting the divider out in a dual plane manifold, like an RPM, like some of the RPM air gap stuff is. Cutting that out adds power at the top normally. 540 with a TR2X intake should make some good torque. Yeah, it still doesn't, even a tunnel ram doesn't make as much low speed torque as a dual plane does. I've tested that a few times. I think there's a lot to be learned from the Ford 300 as far as low end torque goes. Really, really long intake runners on the Ford 300, at least the EFI versions. Getaway, what's going on? Richard, how much ring gap do you need for a big bang? It's still the same. It's all the same on any motor. It's 6.5 per inch of bore. And what's a modular Ford? Is it 3.5 inches or something? It's not very big, right? How about a dual plane with a center divider? Yeah, we talked about that. It's a kind of a go between for, you think about it as a dual plane with a spacer on it, kind of already. Todd, what's going on? It's a pain truing a pit bike crankshaft and then reassembling it. Are you turning it by yourself? Had a dark cool can intake on a 10.5 to 1 compression, 355 with a World Product Sportsman, 2 heads. A dark cool can. So you were cooling the fuel in it. Is that what you're doing? Watching NASCAR. What NASCAR's on tonight? I think if I put the heads and cams from my built motor and throw them on the MPI block, if they're okay, that I can get 325 horsepower and then just run 15 pounds of boost, make 600 wheel. Yeah, we know that they'll take that much. Watching the A-Team, very good. And not the movie. So the original series with Mr. T, I Pity the Fool. I just like my drive-by-wire, about to change the throttle out for a cable one. Richard, not sure if it's been covered yet, as I just joined. Welcome. Did I send you an email? Hope it found out. What is it? Did you have a question, Jared? If you need more torque, there is actually a replacement for displacement. Spray a 250 shot at 2,750 RPM. That's oddly specific, but yes, you'll have a big gain in torque there. Does anyone recall what the stock 5.3 liter LT did on Richard's dyno? Yeah, Richard knows because he has all of his dyno data. Dyno results, LT 5.3. Let's see. Final header airbox. Stock one made a little over 400 and 429 foot-pounds of torque. They're really good. Turbo Sentra, I didn't finish the fuel system yet. Having problems making everything fit. Also, can't fit my intercooler. Uh-oh. Josh, I'm that guy with 0 low-speed torque. Hopefully, 8706 Summit Cam works better than a Sloppy Stage. A Sloppy Stage 3, is that on a 5.3 also? I hope not. That's a big cam for a 5.3. The best tune for adding torque is increasing displacement. Yeah, or a positive displacement blower. All of that helps. I did a BTR Stage 4 NSR truck cam with my turbo. It works great. Roughly a 3500 stall converter. Yeah, you'd need some converter with that camshaft. It is always the wrong cam. Richard, a single plane won't do what a dual plane can do down low, but do you think a dual plane with a carb spacer can get close to what a single plane is on top? First of all, I talked about before, I was speaking in generalities on single plane, dual plane, and you might be able to get that on specific applications. But as a general rule, our testing has shown that there are combinations that don't do that. So for instance, on the one that I was talking about, the dual plane did better than the single plane everywhere, and then they made the same peak power. So if we put a carb spacer on the dual plane, it might do a little better than the single plane. But that's a rare situation because it's such a small motor and it was such a mild combination that it definitely favored the dual plane. On other combinations, usually the spacer would get in between the dual plane and the single plane. The combo works a little or a lot based on all the parts, then add adders. Both intakes have a place that work under those conditions. So many choices. Yeah, the single plane and dual plane, which I've run boost on both of those when I did that intake test on specifically on LSs, they do the same thing under boost. So if you have a bunch less power down low because of the single plane, you still have that under boost. It still makes less power down low. If you build an N8 torque engine and add boost, will it have the same power curves for torque and horsepower, or will horsepower possibly see a bigger percentage increase because of turbo lag? Well, we talked about this. We've talked about it many times, but what you do to the power curve is a direct function of what you do to the boost curve. And then also what you're doing with timing and that kind of stuff, depending on if you have good gas in it or whatever that is, that can also affect it. But if you have a power curve and you add the same amount of boost everywhere, the curve is exactly the same. It doesn't enhance one part more than the other. If you change the boost curve, if it has less boost down low and more at the top, which you can do with turbos, if the turbo comes on, then the shape of the curve is going to be different. The NA one's going to be different than the boosted one. And then also with centrifugal blowers, a rising boost curve definitely changes what the shape of the curve looks like. And even on positive displacement blowers that have short runner intake manifolds, which we talked about last night or this morning, I can't remember, I think it was last night, you also have a change in power curve because you've changed the intake manifold design as well. Let's see. Scroll in. Can we call an 8-carb setup an octaplane intake? That would be good. I like that. The points for that. Dual plane high compression 195 heads and a 212 cam. And then if you say that I'm hoping that the 195 heads are iron heads also, because if you want all the detonation, small cam, high compression, all of that stuff, dual plane, then that would be good. Octapulse. There you go. That's good. I'm having drink for everybody. My insurance may cover the rest of the truck, but I can't stay, which is sad. Back to work, guys. All right, Taylor. Had to vote no because I believe it's 89.4%. All right. 91.3. Nitrous always wins. Richard, I've never had a carb engine besides RC stuff. When you add a spacer, is that similar to increasing plenum volume? I roughly get why the carb needed rejetting. How does it change power? It's not the same as, I don't think it's the same. I don't think it's a function of plenum volume. I don't think that that's what's changing it. I think you're changing the carb signal personally, but because I don't think we don't see, or I don't think we will see the same kind of power change just adding plenum volume. If we can control the fuel supply like with EFI, I don't think we see the same thing. Old school Edelbrock Streetmaster small port single plane. Spray nitrous for low speed torque. Steve Moore says dare to keep engines off nitrous. Oh, Tim, you're watching the Craftsman truck series? The Dart Cool Can was just an Edelbrock RPM air gap. Oh, is the Dart Cool Can? I thought you were talking about a cool can like that you run the spiral fuel line through. It looked like only half a bearing's worth of material made it to the pan. I'm going to upgrade rods either way probably, but hopefully the crank and pistons are good. Yeah, 3.5 inches of bore. Yep. All right, Taylor, good luck. Just at work, I have here in Australia an L76 with nitrous. Engine C's now rebuilding. Been told from a cam supplier a 114 LS8, 282, 290 will be fine for also a later turbo, but pistons from Wiseco. Yeah, what are the, Jared, what are the 50 numbers for that camshaft? What's the duration on it? Is it low 230s, 230, 240 kind of thing? 282 is 232. Yeah, that should be right. RIK 444 times 5, XO5. Oh, those are the pistons from Wiseco. Just wondering if that's the best option as well as a first crank and good rods. It depends on what you're trying to do. You didn't hurt that motor running nitrous on it from a lack of strength of the components. You heard it from something else. You heard it from detonation, probably. So it's not a strength issue because we've run 1,500 horsepower with that kind of stuff, and so with stock stuff. So if everything's right, it's a lot harder to hurt those. After I prove 600 wheel horsepower isn't a problem, I'll simplify and add more boost until it won't take another pass. Okay, cool. Yeah, let me know what happens. More gear and a converter fix a single plane. They do, Scott. That makes makes a really big difference. If all you do is get it up past the area where it was losing low speed torque, and then it works like magic, right? Building an Aero Q4, 243, Struck Norris cam, dual plane, looking for killer mid range. That should be good. In some cases, I've seen dual plane carbureted intake manifolds make more really low speed power than long runner truck manifolds. So that should be good. Mike, on the Big Bang motor, back pressure was less than boost pressure, and inlet air temp was 100 and something, low 100s at 29 pounds because we had ice water in it. What do you think about the comp 276 for a daily driver? I have a 1900 stall currently, recommends 2000 plus. What sticks? What size motor is that? 550 lift, 232. It's a I thought you said it's a 232, 232, 115. This is a good cam for a 393 Ford. That's not the cam I would pick for it, but it will work with the turbo. Can you test a China no-name dual plane? You mean like I don't know who else makes one of those for an LS? If you're talking, I've tested lots of offshore dual planes on small block Chevys and small block Fords and those kinds of things. What RPM range do you think a stage 4 BTR cam with a single plane intake manifold on a 6-liter LS with a carburetor? I don't know which stage 4 you're talking about. But the stage 4 LS3 cam that we ran on the 5.3 with a short runner manifold makes peak power at 7,700. So on a 6-liter, it's going to be less than that. Bathurst 12 hours practicing qualifying is on YouTube. Races tomorrow. That's cool. That's good stuff. Let's see. Did I miss a bunch of stuff here? It looks like I did. Been out of loop. Did you find out why your pickup wasn't making power? I haven't yet. How about a test on a stock cam 5.3 and 1.8 rockers versus stock cam 5.3 boosted and 1.8 rockers? The boosted thing with rockers will just do the same thing that it did NA. The rockers will add power NA, and then the boost will just multiply whatever that gain was from the rockers. How do I get high horsepower on low boost? You make lots of NA power is the way to do that. I feel single planes are good for cars that are hard to keep from breaking loose on launch, soften up the low end torque. Yeah, there might be a need for that, like we talked about with centrifugal blowers too, where traction is an issue, and then that's a kind of a form of traction control as it ramps in the boost relative to RPM. And if you have to detune the combination, if you have to take power away from it, it would be better to have the power where you can actually put it down, which at higher RPM might be a good way to go with a single plane. I'm going to try to run a 6 AN fuel line. I was going to run an 8 AN, but the rail is only 5/16 inlet. You're fine. I will be running V10 stuff this year. If you run 32 degrees under 93 octane, what degree would you run with E85? I'm 32 degrees. I'm sure you're talking about an NA motor, right? You could try adding more timing if it's an NA thing and you're putting E85 in it. You can try adding a couple of more degrees, but a lot of times we see that, especially on NA motors, that we don't run any more timing because the chamber wants a specific timing, and the NA motor didn't respond really very much to E85. Any V motor, any carb intake. What about testing carb spacer with no air filter? We don't normally run air filters on carburetors versus no spacer and velocity stack versus spacer and velocity stack. You think that the velocity stack is going to change something with the carb spacer? Remember the old Torquer and Torquer 2? Not sure if they actually made more torque. They didn't. I have videos up on the Ford versions of those where we ran a performer RPM or an air gap. I can't remember which one it was. I can't remember. I think it was an air gap. And then a Torquer 2, I thought it was, and then a Victor Jr. And the Torquer 2 just didn't do well. So, man, it always takes off on me. Dan, what's going on? We haven't heard from you in a long time. 15 to 20 horsepower shot of nitrous really wakes up low speed. That's true. Can you use an 8 LT crank and an LS? If so, what rods and pistons? I have no idea. I've never tried to run those. I don't even know what the stroke length is or anything on that. But I thought people were doing that. But there's so many other cranks available for LSs. I remember guys arguing about that on one of the groups. Jared, 229, 244 duration, currently tearing down, have a cylinder full of fuel, maybe suggesting hydrolock with a bent valve. Yeah, if it's full of fuel, that's not good. Carb spacer is a placebo effect. No, we've tested carb spacers a lot. Sometimes they don't do anything on some combinations. Sometimes they do a pretty good bit. And there are so many different spacers that there's so many that you can test because they go from a half inch all the way up to 2 or 3 or maybe 4 inches. I did a stack of them where we stacked them up, I don't know, 20 inches tall or something like that. Low speed torque tune. I'd love to see a dyno run with a Ford 300 inline 6 with a cam advance. I want that shift the torque curve further left. It may or may not. Because the camshaft might already be at its optimum low speed torque uh, mix of valve events already. You don't know that advancing it is going to add low speed torque because it might already be at that point. Because if you advance it too far, it's going to start losing power, and it might already be there. So we don't know what that is. I tried advancing the LS9 camshaft, which I thought for sure would add more low speed power because it's missing all that low speed power. It has such a wide LSA, but that didn't work. So you don't really know that until you test it. Can you test a 4-barrel TBI retrofit on a single plane versus a dual plane? The guys at Westech have done that and had some of them work on one intake manifold better than the other, or they weren't working really well on a dual plane, I don't think. If it's working right and it will repeat and give you, and you can tune it and give you the right air fuel and stuff, the 4-barrel thing should make comparable power to a carburetor. Mike, I haven't run air to water intercoolers before. Is the low back pressure on the Big Bang 6-liter from being so far from the turbo limits? Yeah, the twin S475s are a long ways away at 1,500 horsepower. They're still 500 horsepower from their maximum flow limit. So they're big enough and have big enough hot sides where back pressure isn't an issue. And we weren't concerned with that anyway, because we didn't want there to be a problem. It has less to do with the cold IATs. In fact, the cold IATs, because it adds power, would actually add back pressure. Stage 4, does it equal 3/4 race? What cam would you pick for a 393 turbo Ford T56 Magnum? None of that. Well, some of that stuff's important, but I need to know what you're doing with it. What is important for you? What are you trying to achieve? You're trying to achieve something specifically here, and it's not maximum power. It's something else. So the camshaft that would do that is going to be some kind of combination that will work for your needs, and not something I would recommend unless I have all the information. Richard needs a 300 inline 6. I agree with that. And a 6.8 liter V10. Yeah, both of those on the dyno. (15/16) cam. I love this cam, but I'm applying something closer to 600 lift on my next short block. Just want to stock with fresh bearings. Oh, Dan, I just tried to put a M90 on it, and we couldn't get it to make power yet. How does the 85 help an NA motor? It does help some NA motors that are high compression. It can take advantage of it, particularly direct injected motors. It seems to gain from high compression motors. And especially if those motors in the vehicle, while they're running hot water temperatures and all that, if they're running, which Ford certainly does in their Coyotes, if they're running them on the limit of knock, if they're always on the knock sensor to try to maximize power, and you put E85 in it and you get a cooling effect and you have more octane, it will add more timing and make more power. But Brule did an interesting test and said, I think that's all from you guys adding timing. That's why we're getting a gain. And he said, don't allow it to change the timing. And it still added power on a direct injected Coyote motor. So the E85 did work on that. I've tested a lot of times on naturally aspirated, junkyard LS motors, and doesn't really change the NA power very much. But on every boosted one that I've ever run, including, blow through carbureted stuff, turbo EFI stuff, draw through 671 blower stuff, all of those, it always helped power. My preference on all my Ford small blocks or big block single plane intakes have always been better performers. Okay. LS3 stage 2V. Okay. Wish they stopped calling cams by these ridiculous names, and that everyone made manufacturers publish all specs. The problem with that from the manufacturer's standpoint is that somebody goes to a great deal of trouble to test and design camshafts and then publishes all of the information on the camshaft, then all the other people just copy that camshaft. So they don't share any of the costs for what it took to design a really, really good camshaft, because people that develop them make better camshafts. If you spend time to test multiple different camshafts to find out which one is the best camshaft, and then somebody else just copies it, they get all the benefit of your development. And so I understand why people are, a little tight-lipped about some of their specs. Been driving the 6.8 liter V10s at work recently and really love them. I don't think I've ever been in a V10 truck or van. Now I feel like I'm missing out. I'm scrolling back here. Jim, a Viper. No, the V10 we're talking about, if that's what your question is the Ford one. Thanks for the E85 answer. Added flex fuel sensor to the 383, but haven't added boost yet. E85, Boost loves E85. The Triton split pin crank makes me nervous. Hopefully the stock crank can handle a lot. I'm hoping so too. What's a good company carburetor for a mildly built 6-liter? I used to like the Brawler carburetors a lot, but I think that they come up in price. Is it worth using an 8 LT crank and my aluminum 6-liter cost-wise, or should I just go with a 4-inch stroke? I was hoping for more displacement without the short sleeve problem. A 4-inch stroke is fine in a standard block. You shouldn't go more than that, though. Dan, I've been working every day, and every time I finally sign on, I've missed the show. Yeah, I haven't been doing 7 o'clock ones that often. Sometimes it's been happening earlier. But if you're working every day, then you're just, busting hump for the man, making lots of money. That's good. For normal driving, the engine doesn't need to make much horsepower. No, for cruising down the road, it doesn't. 40 to 50 at most. Do you think when we have low RPM drivability issues, it's overlap and not like running at low RPMs and the amount of torque? Our conversation about low speed torque has nothing to do with drivability. I mean, they're related, but when we're discussing those two things, the difference between a single plane and a dual plane, we're talking about wide open throttle stuff, not cruise. Now they are going to be related. The single plane, the fuel mileage is probably going to be worse on the single plane at cruise, and it's not going to feel as good. And I don't think it'd be quite as drivable, but that's a different thing. The part throttle part of it is going to be different than the power output. Stage 4 BTR NSR truck cam is 224, 230. Yep. Yeah, that's very low lift. Goofy, what size was your motor? Given the fact that we've run stock cranks at the level that we've run them at, I think if you go to a forged crank, which most people don't do, they go to forged rods and forged pistons. And then I think it would be a toss up between when you get to the limit of the block, the factory block, and the crank. What's the best gear for a 4L80? It depends on your tire size and what you're doing with it. Cylinder 7 boost leak. There's no boost leak. We had plenty of boost. It's easy to pinch those wires in the gasket on that one when dropping. The intake manifold that we use has O-rings in it, and they're in place when you put them in, so it's not a boost leak on the. If you're talking about the truck, that's not it. Maximum horsepower and top speed runs 393 Ford. What cam? So what heads and intake manifold does that have, and what turbo are you using for it? Because it might be that you can get to the limit of the turbo with a milder camshaft and not have to worry about a lot of camshaft that makes the drivability less. The Summit Pro LS stuff is good. I do recommend that stuff. How are the 12-to-1 compression DI Gen 3 Mustangs doing so well with boost? Because they're really good NA motors. And on a DI motor, you have to worry less about detonation on a DI motor than you do on a port injected motor. $5,000 LS billet short runners out there for that kind of money. It seems you could get a dual runner manifold design with internal flapper valve and have the best of both worlds. Yeah, $5,000, you should be able to build a really nice manifold. Can't someone buy the name brand cam and spec it out and reverse engineer it like they do in China? You mean can't somebody do that? They already do that. Big Mountain, I don't understand your question. Tony, your 3-valve stroker blew up. Dan, you got to ride in a V12 airplane? What plane was it? And what V12 was it? Oh, P-51D. That is a good one. If you go to the junkyard and look at the white pipe on the V10, it's bad. So it's not. Are you saying it's not good? It's not going to be like the one I want for the turbo combination. Mike, what do cam profiles matter a ton about? I can't remember what your previous thing was. Mike, to add to that, I bought a Shelf 388 cam from BTR. A year later, they had a totally different cam lineup for turbo stuff that's better. Well, and that should be a good thing to you, that you want a company that's continually developing their stuff. It's not that they made an inferior thing. It's just that they made something that was better than they did before, and then they made another step up. So they're constantly trying to do better and better products. I think that can only be looked at as a good thing. It's good for them to continue to do development and be a better company and offer better products. It's also better for the industry that everybody should do that. High compression engine, 13.5 to 1 or so will be streetable with 85. Yes. You're in the process of putting a 2014 3-valve V10 and a 71 F100 truck. Very cool. What's the FM carb starting point for a 6-liter LS with LS3 heads? If it has a camshaft in it, it's going to need to be at least a 750, and I probably might even be thinking about an 850. When was the last time anybody degreed an LS cam? Yeah, I had a guy do a rant about that on one of the groups about how every cam has to be degreed. I'm like, dude, you obviously do not know the market. Tunnel rams are good.
Oh, yo, dinner's ready.
Mike, at this point, you have something come out that's better from the same manufacturer, especially when you can't even directly compare it. You could compare the old one to the new one, but if they don't even offer the old one anymore, it becomes irrelevant, right? And honestly, I've seen obviously I'm privy to a lot of this kinds of testing. And if you see a camshaft where they made more power, let's say you had a camshaft and we had it on some kind of combination, and the new one makes 8 more horsepower on a turbo combination, I wouldn't bother changing that because you'd have to multiply that way out for it to mean anything on a turbo combination. And you could always get to the end of your turbo with the camshaft that you have. So I wouldn't really be too concerned about that stuff. Is there anyone here who has done a Navigator swap and an S197? Does anybody know? For a regular guy without a dyno and lots of knowledge of fine-tuning a carburetor, just basic adjustments, would an Edelbrock or Holley do better for low-speed power? I like using a Holley because I spent more time with them. Edelbrocks, I haven't spent a lot of time tuning them, so I'm not saying that you can't, but I think for me, I would put a Holley on it. If it's a daily driver, I would have no problem also if they had an intake manifold for it, putting a Quadrajet on it. Richard, have you dynoed any jet boat engines? Yeah, lots and lots of jet boat engines on the dyno at Westech. They run lots of boat engines there. On your truck, did anyone suggest a torque converter on its way out? The torque converter is brand new, and so is the transmission is a rebuilt one, so it shouldn't be that. I think it's ground. I'm pretty sure that it's ground issues. Exactly. My very mild cam is great for drivability, even with the turbo. Yeah, the turbo the drivability should be what the camshaft is. And then the other things that you do, the converter and the tune and all that. The turbo shouldn't affect like light part, throttle cruise, and any of that stuff at all. Yeah, so instead of asking for cam specs, the manufacturer buys a single cam from the big names and reverses it. So, but then that's not a manufacturer. That's just somebody who's stealing other people's products. Is that what you're talking about? Jet boat engines dyno themselves. Berkeley Pumps has a chart. If you have this impeller, turn this RPM, you're making this much horsepower. Yep. But on that, Dan, wouldn't the boat that you have that pump in, wouldn't that, I mean, that's going to affect the drag, right? So for you to reach that RPM with that pump in a light boat is different than reaching that RPM with that pump in a heavier boat, right? Am I not thinking about that right? Would you go with turbos on a Godzilla or would you go the supercharger? The choice between those power adders has nothing to do with the motor, really. It has everything to do with your personal choice. Do you like the way that one looks? That's why when I do the videos, I've shown time and time again the different boost curves and things. Usually people don't pick those on what's the best. A single turbo or twin turbos make more power per pound of boost than all of the other power adders, than all the different kinds of blowers, centrifugal roots, twin screw, axial, whatever, because you don't have to drive the turbo. Guys are going to argue that, oh yeah, but it has back pressure. It's not even in the same league. So it could be 100, 200, even 300 horsepower to drive a blower at real high power levels. We're talking about these kinds of street blowers, street strip blowers, whereas turbos don't have that. So from an absolute standpoint, turbos are going to make more horsepower per pound of boost, but that's not why people choose it, because there are other things. Do you like the way that turbos look? Do you like the way that their response rate? The bigger the turbo, the less responsive it is. Do you like having a big blower right in the middle of the V where God and nature intended it to be? Do you want to deal with potential belt slippage? Do you like the centrifugal? There are all these things that make people decide for these, in favor of these different types of power adders. And it's not just about power. How is cam selection affected when applied to a large CID engine that would be used for towing? Cam selection for a towing application, you would still look at where you want to make power. You'd look at the RPM range where you want to make power and pick the camshaft that's going to be effective in that RPM range. And for towing at part throttle too. I was told that installing 862 heads on a 6-liter would help with low end power for towing. That is true, because an 862 head is, I have the video up where we tested the 706, which is the same as an 862, versus a 317 head, which is the head that came on that 6-liter. It adds compression. It has a smaller valve. It has a smaller chamber. It has a completely different chamber design. It has smaller port volume. It has a better coefficient of discharge. And so it will definitely improve low speed power. If so, do I need to copy the ignition and fuel from the 4.8 truck to get the heads from? No, you don't need to do that. You will need to probably tune it, but you're not going to take the ignition and fuel from the 4.8, because that's going to have a different size injector than your 6-liter does. And your 6-liter is going to be making more power, so you're going to need to have that tuned. I would argue that single versus dual doesn't have much effect at 1500 to 2000. I don't know if I've ever loaded one down at 1500, but we have loaded them at 2000. It gets harder to run a carbureted combination, to load a carbureted combination at 2000. I'll go back and look and see if we have. But unless you think that 3000 or 2500 is mid-range, because it makes a big difference there. Well, they made something they claim is better, but I don't know what the difference is. And like everyone else said, it's really easy to get one and copy it. Yeah, if it came from the guys at Brian Tooley, they didn't copy somebody else's cam. They're the ones, they have their own dyno. They have a Spintron. They grind their own camshafts. They test more than anybody that I know. And so they do really good work there. But you should be able to ask them what the difference is. If you get a guy on the phone that you bought the camshaft from, he should be able to tell you what the power difference is between whatever those two cams are that you're talking about. Man. I'm scrolling back. Still, I don't know why I haven't caught up. Let's see. I'm thinking on a 4L80, I'd do 411s, get bigger wheels or tires. 500 wheel horsepower, 6L80 HSV, Grange, Australia, R430s worth the swap from 370s for a quarter mile stuff. Take a look and see where you are. What RPM are you going through the lights at, and at what gear? So if you still have more RPM left in that gear, there's a good chance that 430s will help. But you got to do the math and make sure that you're not getting to a point where you're going to do another shift, because most of the time that slows things down. Well, Mike, I don't understand what secrecy is holding people back. I did talk to Eric today about because I got information back from the guys at Holley about running tri-power 2G EFI carburetor things that are fuel injectors, throttle bodies. They have those, but they only sell them individually and only run them individually as sniper units. But Eric thinks that we can get 3 of these wired up and run it as a tri-power with a Holley HP. So I'm hoping that we can do that. So that would be very cool. The rooster tail just gets bigger. The traction isn't the same as the propeller. So are you saying, Dan, that a 17-foot jet boat with an 800 horsepower motor with a impeller or a B impeller, whatever impeller it would need, is going to go the same speed as a 26-foot boat with the same combination? I have 273 open gears in it right now. That's pretty highway gearish. Got my engine out of the Mustang, but I'm unsure if I should go Navigator 5.4 or Aviator 4.6. So it's going to be easier if anyone here knows. I don't know about fitment. That would be the thing that I would worry about. The 5.4 obviously would make more torque, but I don't know if the long tubes will fit because the 5.4 has a different deck height. So it's going to raise the headers up. And I don't know if things are now going to fit. Sometimes when you did that, the tubes, if they're long tube headers, come up and hit the underside of the body. What's the stock and turns power limit on the Navigator? I don't know. With ring gap, probably you could make a lot of power. Yeah, we're at 85 thumbs up and 103 people. We need a couple more thumbs up. We need to get up to 100. So we're going to close out our poll. The dual plane intake is better than the single plane for 90% of performance applications. 77% are saying yes. I'm scrolling. Oh, this wherever I got cut or whatever. I got attacked by the dogs. They were jumping up on top of me on the couch and decided that while one of them was standing on my shoulders while I was sitting on the couch, that the other one would come up and attack them. And then they started biting each other. And I was collateral damage. I still have the 4L60 that came out of the truck in my garage. Maybe I should try to build it up. Logic, thank you very much. Probably on the $300 range. I'm thinking pulling GM 6.5 out of my old RV for a carb small block. Not the same speed, but the engine RPM will pretty much be the same. Okay. The hull drag will determine the speed of the boat. Ever seen jet drives with huge rooster tails? Yeah, the Jettivators, right? Didn't they used to have those? I remember those on the movie. It was Live a Little and Steal a Lot. They had a Jettivator on their boat that they were they were doing the James Bond race around the little waterway things. It's pretty cool. I like those. I think all jet boats should have those. They should have to have those. Oh yeah, we did. We're 101. That's probably the first time that ever happened. If you have a lot of cubic inches, is it worth going single plane since the torque may be higher on more cubes than a smaller cubic inch motor? Yes, if you have a big cubic inch motor, most people go with single plane stuff. Like when we run big block Chevys, 496s and up, we usually put single planes on them. You can run dual planes, and if on a big block, I would run a dual plane on a 454 if I was just using it as a stock motor with a stock cam and stock heads. Excuse me, and I was using it for towing, I'd use a dual plane. I wouldn't use a single plane. If I was building a performance big block that wanted to run out at 6,500 RPM, I would use a single plane. Nathan, I tuned my Barra on the street with cam timing zeroed and then started to adjust the cams to the point where the tune wanted more fuel. Seemed to pick up more bottom end and a little top end. So did you do that based on an O2 sensor reading? Dual plane with a QJet. I like the QJet option. Now we got to get you to 3,000 subs. That would be nice. I think it's at 280 or something right now, right? Haltech and a wideband with data logs. Yep. That's the way when we're running it on the dyno, we know that if we make a change in something, like if we take one cam out and put another cam in and we don't do anything to the tune, the airfield will get leaner where it wants to make more power because it has more flow. So all we have to do now is add the amount of fuel that it wants, and voila, we've made a lot more power. But it'll add the power even at a leaner mixture. But then it gets better when we put the fuel in it. The BTR truck nose can be a good cam for my 6-liter. Yes. I want to see a cheap variable length IR setup. A variable length IR setup definitely is doable. I don't know about the cheap part of that, though. A Draggy is probably a really good way to substitute for dyno testing. I run big blocks my whole life. To me, single plane means tunnel ram. Well, single plane would be different than a tunnel ram.
Oh, yo, coming in.
Race boats barely touch the water. Yeah, if they're prop boats, just the I guess they just want the lower third of the prop touching. That's it. I've got a comp 212, 218. Should I go straight to 4 degrees advance? I don't know. I don't know what that will do. I don't know if it already has. Most cams already have 4 degrees of advance built into them. So maybe you already have more than enough. And on that note, it is time to go. Thank you guys all for showing up. I will be back tomorrow. It's Friday night. It's time to go party all the way till, I don't know, 8 or 8:30.